Hi. A few days ago, it is shown that on the official website of CMC, the Hypatia and the Fryer and the Galois are shown. As we know that these three contests are all cancelled due to some inevitable reasons, we have to say. So I can say that, how do I say? It is that I'm going to do this year's problem on the test condition. I promise that I have never seen the problems of Hypatia of this year in previous time, so it is my first time attempting it. Okay, well, it is a condition that you need a calculator. Okay, not of course phone is not allowed, but you need a time. I mean, you need a timer to mark your time. Okay, which is at here. And let me see, marked okay in front of. And at that time, it is mostly it will ask you to write to fill the bubble sheet. It is just specifically what your name is and your grade is. Name and grade and what contest you are taking. Just remember, don't write that wrong. Like, don't write your grade and something and write wrong. Because if you write wrong, they will just identify you as 0 marks immediately. So that is why this people get 0 marks. Okay. So the test will start in 30 seconds. 28, 27, 26, 25, 24, 23, 22, 21, 20. Pretend you are getting nervous. Do not discuss the problems or solutions from this contest online for the next 48 hours. The name, grade, and 5, 4, 3, 2, 1, begin. I'll send us 5 per bag and mangoes 12.5 per box. Bag include 2 mangoes. Box include. Okay. On Friday, a chef purchased 12 bags of avocados and some box of mangoes. If the total cost was 135, how many boxes of mangoes were purchased? 12 bags of avocado. 12 bags of avocado is 60. 12.5 is 6. So in this problem, it is asking you when the cost was 135 and you buy 12 bags of avocado, how many boxes of mangoes will you receive? Problem B. On Saturdays only, there is a discount on the price of bags of avocado and 20% discount on the price of a box of mango. What is the total cost for 8 bags of avocado and 4 bags? Well, in the test, you need to write specifically, just like, because I say this is under the test condition, original bag of avocado after 5 per bag. Eight bags of avocado and 4 boxes of mangoes. 36 plus 40 equals to $76. Okay, so now we are completed the problem B. Problem C. A Monday chef needed. Okay, so it is asking us, it is just giving us enough boxes. What? 100 avocado and 75. Oh, it's just enough, not it's exactly enough. Okay, so it is a box includes. So mass dot flow plus 1 is 17. So it is a total number of avocados times bag times the money for each bag is $85. The money for avocado is a box contains 15 mangoes. Plus 1 is 7. 7 times this is 87.5. 85 plus 87.5 is, I feel that I'm somewhat not at the contest condition. So it's a problem for problem C. D. D is that on Tuesday, chef makes special tarts which are products if the spends exactly 75 on avocados and mangoes. Determine the greatest number of the tarts he could exactly make. So 1 avocado and 2 mangoes. Let me think. So let's assume it's 15, 24. Okay, 1 avocado and 2 mangoes. So we assume that he buys 6 and he buys 12. It is definitely enough. So if we assume he buys 6 avocados and 12, I mean a bag and a box. Wait, we can just start. So means the money is definitely enough. It's 5 plus 12.5 is 17.5. So we try 18. Bag 18, which is 3 bag, and 36, which is 3 boxes. I'm just attempting. So it is 3 bags and 3 boxes. At this point, it should be, let me see. It should be 3 times 5 plus 12.5. Okay, so if it's 75 points. Okay, I know. 26, 24, 4 bags, and 48, 45, which is 4 boxes directly. Times 17.5 is 670. So he only has $5 left. In this case, he can only buy 1 boxes of this, but according to the law, he can only, okay. So he can use 24 at most. Problem 4. Okay, so I have done the first problem. Now let's do the second. The parabola with the equation 1 has the vertex at origin and the y-axis as its axis of symmetry for any point PQ. What the heck? For any PQ on the parabola, we can form a parabolic rectangle. This rectangle will have one vertex at PQ, a second vertex at the parabola, and the other two axes. Okay, I know. Okay. We can make some basic analysis for this. So it should be called as this. And this has the formula of 14x squared. So we can find that this is same to this. The value of y is same, and the x is positive and negative. So we can see that if this is a, b, then this is going to be, x and y. And it's going to be negative x and y. This is going to be 0 on the, no. 0 on the y-axis and positive. Okay. So in this case, if one is this, the other is going to be this. And the other case, it is going to be this. And the final one is going to be this. So this is the first one. Okay, trying my best. Okay, the second one is, what is the area of having the parabolic rectangle of having the one vertex at -3, 0? Width. So we can define that its width is definitely 0 minus -3 is 3. And the length, wait. So it's -3 at axis. Wait, so this is length. Since it definitely has the y-axis as 0, so since of having one vertex at -3 as 0. Why? So the two, we can get that the 2 points are -3, 0 and +3, 0 respectively. 2 points. X-axis. So we need to calculate that the first one is, another one has the y value of 2.25. So we can calculate based on 143 squared is equal to 2.25. So it has the y value high to 2.25 and has the -3 and +3. So it's 3 plus 3, okay, is equals to 6. And 6 times 2.25 is going to be equals to 13.5. Okay, we got problem 3, 2. Okay, determine the areas of two parabolic rectangles that have a side length of 36. Problem 3. Determine the area of two parabolic rectangle. Well, it will have possibilities. What? 36. If it have... So it will have the... If the width is 36, which means this is going to be 36, we have to divide this into two cases. So it is negative 18, 0 and positive 18, 0 with the two origin dots. And based on this, we are going to calculate the y value for this, which the y value is going to be 14 times 18 squared is going to be 320, 81. So it will have the possibility that it has the length of this. And another possibility, we can also do that if the y is equal to 36, which is this. So in this case, x is going to be 12. So it will have negative 12 and positive 12, which in this case, it will have 24 times 36. So we'll have two different results. So which in this, it should be counted as respectively, it should be 86, 4. And this should be 9 times 9 times 6 times 54 times 54. 26216. 26. What? It is an easy thing just using a calculator. 2916. Okay, so the last problem is that it is asking us to determine the area of the parabolic rectangle which length and width are equal. It is asking us length and width. Okay. So we know that according to the graph, the length is going to be 2x because the length is going to be 2x because the 2 points are negative x0 and positive x0 respectively. In this case, we can make and the width is equals to y is equals to this as the problem has stated. So which in this case we can able to make a formula. So we time both sides by 4. Okay, there's only one solution. X minus 8. Oh, sorry. Or x is equals to 0. It is not possible for x is equals to 0. So in this case, x can only be equals to 8. So which in this case, it is going to be 8 times 2 square. 64. So this is going to be the area at last. Why is it 16? Because it has a length of 2x. Remember, 2x. Oh my god, problem 3. I see something very scary for problem 3. Okay, a triangulation is a regular pentagon, is a division of its interior into rectangular regions. In such a division, each vertex of each triangle is either a vertex of the polygon or an interior point of the polygon. The triangulation of the regular pentagon with n is larger than 3 and k is larger than 0 interior points with 3. So what does this mean? 1, 2, 3, 4, 5. So what is N? N is vertices and K is interior points. Oh. Well, this is what loose habits like to write a problem in a very complex way, but they are actually very simple. I mean, they actually should be defined in a way that is much simpler. So in this case, what does this mean is TAB, where A is representing as vertices and B is representing as what's that called? Interior points. So it is, for this way, it is calculating about how many pieces it can make. So it is the number of triangular formed by any triangulation of the regular polygon with n vertices, and k interior point is constant and denoted as nk. So this is how many pieces of rectangles? Well, a word of, so in this case it is equals to this, and in that case it is equals to this. Okay. Waterloo likes to explain things hard. Okay, so we can do that T 3, 2. T equals to 3. So it is a triangle. Okay, that states that it is a regular polygon. Okay, so it makes the problem getting easier. Okay, we have 1 point. So in T3 1 can make 3 points at most. At least one of the rectangular region. Wait, can this be intersect? I mean, can they intersect each other? Okay, regular of point, triangular, and K. Connecting pairs across anywhere. Okay, so it cannot be across. Okay, so this is a problem. Okay, so that's why I make this problem hard. I think the reason is that the fact is that it can make into its largest number. You can see that in this case, 1, 2, 3, 4, 5. So it has the total area of 5. So it will have the chance of this. So I can see that there is one potential solution in a deep analysis. So in this way, it should be centered in a way that in the case that if it's dividing into a rectangle, you can see no matter what shape. So it will, the first way, it is dividing into the cases where this represents. So for example, if we set as TAB, so in this case, things should be like this. Okay. First, cut should have attained A in TAB at maximum. Two respectively. Why I say it is going to be 2? Because it is going to regard 1, which is its space shape. Well, I just hope it is going to be correct. Hope it is correct. So we are going to derive a general formula, which is this. This is basic pre-calculus 11 knowledge. S in the terms of B is equals to this. So in this case, we just plug in this. Plug in values. A is equals to 4, B is equals to 100. 99 times 2 plus 4 is equals to 202. Perfect. Okay, so we have divide. Okay, so for problems this, we only need to derive the basic formula. 3, derive the formula n plus n minus 2n minus 1 equals 3n minus 1 is equals to 2020. 2021 is equals to 3n. What? Okay, let me check. Do I write anything wrong? 2n, 3n minus. Oh, well, I forgot to do that. Okay, 2022. N is equals to 6. Okay, I'm again going to use calculator. I promise that I can definitely calculate this out by brain during the time, but under case condition, just to save time. Okay, I'm going to check what time I still have. 44 minutes. So I'm going to do the last problem. Let x0 be a non-negative integer for each integer I is larger than 1, larger than or equals to 1. Define this. Recursive function. This is recursion. This is a problem that if you can give me a calculator, I definitely can solve this. But I mean, if you give me a computer that can code, I can definitely solve this. But at that time, computer is not allowed. Okay, let me see. So that x2 minus x0 is even for all possible values of what the heck? x1 is equals to x0 squared plus 1. So x2 is going to be equals to oh, 0 has to be a positive integer, but does that matter? So it is going to be the way that they expected you to do. Plus even minus odd. What? Divided by x0. So in this case, if xo is odd, then odd square is odd, x0 is odd, odd minus odd is even. Well, we can prove this is definitely even. If x0 is even to the power of 4 is still even. Even minus xo is even. Even minus even is even. Using easy calculations. Boy. Okay. So we have done this problem. Problem A. Now we try B. B is required us to show that, okay. Show that x2026 minus x2020 is divisible by 10 for all possible values of x0. Oh my goodness. I'm going to try to expand this, okay. Show that this is going to be divisible by 0 for all possible values of x0. This is getting me confusing. Why? This problem is show that x2026 minus x2020 is divisible by 10 for all possible values of x0. Oh my goodness. A4. I'm just going to try random choices. Is equals to a squared plus 2a6 plus a4 plus 2a6 plus 4a4. 8 6 4 6 4 2 a8. It is definitely going to be unique. 4a6 6. Okay, I'm getting it clearly. Well, I think it is a problem that can be solved easily through binomial expansion, but... Oh, it is binomial expansion. Okay, it is binomial expansion. So the last set must be 1. Okay, it is based on the formula of this, and I can see. Okay, even though it is binomial expansion, I cannot see the usage of it. Show that x2026 is minus x2020 is divisible by 10 for all possible values of x0. Why should this be like this? Okay. 36 minutes. I think I'm going to be bad. Divisible by 10 for all possible values of x0. x1 is x0 squared plus 1. x2 is x1 squared plus 1. x0 plus 1 squared. x0 plus 1 plus 1 plus 1. If we want this to be divisible by 10, so 1, that's 2. Not sure about its coefficient. 1, 4, 6. Numbers will be changed. Constant. I am able to try the cases through this. Divisible by 10 for all possible values of x0. Integral in it does not. Maximize linearization. Is this going to be inherited? Okay, we list out the first two terms is x1, x2. We list out three terms that we know based on calculation. 0的平方加1 x 次方加上4x 0的2次方。Inherited does not fit the inherited. If I can't achieve B, then I can't achieve C, because I think C is originated from B. But it's also hard to check whether they are at 0. We can check that they are divided by 2 and divided by 5, but it's hard to add their sum together. Life is getting me hard. 27 minutes. Divisible by 10 for all values of x0. C4 0, C4 1, C4 2. Okay. So it's going to be 3. 40 52 0, C 40 52. So it must be originated until C 40 to 50, 40 52, and C 40 40. So this is coming from here. And the first one always have this difference. 25 minutes is divisible by 10 for all possible values of the arrow. Why? Okay, 40 40, 40 52. X4, X5, X6, X7, X8. I can't actually. It's definitely not the correct way of doing that. Okay, I know. One 4 6 4 1。641，然后是第4列 C1，2025的463，2022是6，2021是8，2020就是10了。A8 plus 46. I have the way of proving this in this type. C6 0 1 2 3. 16 to 2, which is 60 minus. Okay, I'm now at the correct position. Wait, it has 8 terms instead of 7. Yes, it has 8. I mean, include the last one. 16 divided by 8. Wait, it has 9. C8 0, C8 1, C8 2. 8 0, 8 1. 2023 is going to be at 2022 is going to be this, and 2021 is going to be this, and 2020. Oh my goodness. C6, CO64, CO64 1, CO64 2. Well, it is also not a correct, it is also not a smart way of doing this. I mean, it is impossible to be done, given the amount of time. 24. Geometric sequence, sigma. AR n minus 1. Yo, 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 yo. O 16 X 32 624 啊。Minus X 2020. X 2020, in this case, it can be achieved by anything. Minus X 2020. So this minus away. Okay, so it minus 2020 is represented minus everything that is before X 2020 away. So I hate recursion. Recursion problem. If it's at 1, it will have the quality that it is going to be at 5. 6, 7, 8, 9, 2, 4, 5, 5, 5, 6, 7, 7 square is 9. 0, 0 square is 1. Okay, we get the idea. Now what we need to do is we only need to list out all the possibility of its last digit and we are done. 9 square 2, 2, 4, 5, 5 square 5, 6 square 6, 7. 2, 3, 9, 0, 0, 1, 1, 1, 2, 2, 4, 5, 6, 7. Wait, is this 7? 2 plus 3, 3 squared, 9. 9 plus 1, 10. Okay, 9 plus 1. Okay, so I calculate wrong as some squares. So it's 9 and it's 9. Wait, what? 0. X 2020. X 2020 plus 1. 3. 3 squared, 0. 1 squared, 1. 2, 4, 5, 5, 6, 6, 7. Wait, it must be 0. 4, 5, 5, 6, 6, 7, 9. 9, 0, 0, 1. 1 divides 1 minus 1 is going to be. So we can try whether it's going to have a sequence. So we set as x is equals to 1, 1 squared, 2, 4, 5, 5, 6, 6, 7, 7 plus, okay, 1 plus 1 square plus 1 is 5, 5 square plus 1 square is 6, 6 square plus 1 square is 9, 9 square plus 1 square is 4. 4 square plus 1, 4. Hmm? 1 plus 1, 4, 5. 5, 6, 6, 7. Okay, 1. If it starts at the digit 1. Okay, I'm getting everything messed up. Okay. I'm getting everything messed up. 1 square plus 1 is 2. 2 square plus 1 is 5. 5 square plus 1 is 6. 6 square plus 1 is 7. 7 square plus 1 is 0. 0 square plus 1 is 1. 1 square plus 1 is 2. See? It has a rotation here. It has a formula rotation. So in this case, if 6 minus 6, I mean, not only at x20 to 6 minus x2 20, if it's for every 6 digits, if it's at here, 27th or 8th or 9th or even 10th, it will all have the result of 0 because it's a squares. I mean, it is a squares with a formulate steps for each 6. So it's definitely 0. I finally get this one out. Well, it gives me 12 minutes left. Okay, just remind me after 2 minutes. I know you won't. Palsar chooses a number with 1 less than n less than 100 at random and sets x0 at n. Determine the possibility that this is going to be divisible by. Well, I forget to mention that for every problem that requires 2570 works as about. I still forget to test 3, 0, 4. I still forget to test these 4 numbers. 3 square plus 1, 0 square plus 1, 1 square. 30 125 670. Work as above. 7 70 125 670 as above. Work as above. 9 square 2 256701. Work as above. I forget to mention the 4 possibilities that will occur. Okay, so I have done this. Parsa chooses an integer n with 1 less than n less than 100 and random as x0 as n. Determine the possibility that this can be divisible by 105. Oh my goodness. Okay, I know I can't solve this problem, so I just directly pick it up. I'm going to check the problem for the last few minutes. Okay, I only have 9 minutes at this point. Okay, so I have 6 boxes, correct. Okay, I'm getting it right. Okay, I think I can do this problem. So I'm just going to trying my best to think about the last problem in the last minute. Parsa chooses an integer n with 1 is less than n less than 100 and random and sets x0 at n. Determine the possibility that this is going to be divisible by 105. What the heck? What the freak? 105 means that 2. It means we can state nothing at this point. Eight minutes left. Trying my best to think about this problem in the last minute. 105. It means. So in this case, if you can't get problems due to partial marks, you can still write something. It can be divisible by 100. Well, I don't think I have enough time to write it. So you just start by this case. But in this case, you need to mention 100 numbers. So which means if it's the beginning number is at the rotation of 0, 1. In this case, I can only serve a plan to write this 0, 5, 2, 6. Okay, so it shows that the last digit is right. So it has one, what's that called? Rotation. Well, it is a fact that what I try to solve in this case is that you try to, what's that called? Make the number up. I mean, you can try to list out the possibilities like a series of rotations in separately, and in this case it will be back to here again. Well, in this case, a way is that you can try to list out, I mean by some parts, I mean all the ways that is able to work out, so that as a result, you can just, in this case, you can analyze them one by one based on the end of the second digits, and it will be fine. I mean, and by the way, that even though I try to say this in test condition, I still doesn't write this in the way like test. I mean, don't learn me when you write the actual test, because if you learn me like write like this, and when you finish the test, you find that you get every problem right and you haven't get any marks for steps. 78, 6, 7, 87.5. 4 minutes. Okay, time's up. So this is the film about me, trying the Hypatia contest, and thank you. And this is the end of the video. See you tomorrow.